So far, we've used strings a whole bunch without actually manipulating their contents very much. But most of the time when we're doing text processing in some kind of application, we spend time examining the characters in a string, taking them apart, putting them together in different ways, building new strings, and all that kind of stuff. So as an example, think about the problem of extracting words from a string representing a line of text. Okay, to get the first word, we would copy the string's characters to a new string until one of two things happen. Either we reach the first space in the string, so that would be if the space character was what we call the delimiter, the character that tells us we've reached the end of a word. So either we reach the first space character, or we reach the length of the string, if we get to the end of the string. So let's take a look at a code segment that uses this strategy. So you can see this is our sample string, hi there. This is the variable that we're going to use to hold the first word. And it's initialized to the empty string. We're going to loop through every character in the string from I until the length. Or if we get to a space, we're going to stop. Notice we're using char at. Char at, if you remember from the Caesar problem set, returns a character, a char, not a string. And so we're able to use the equals equals operator with the space character. And if it's not a space, then we just tack on that character to word, which is our accumulator. So as you can see, this code combines these two tasks of finding the first space character and building a substring of the original string. Okay, we can actually solve this in a much easier way if we just use two separate string methods that are designed for those tasks. The first one is called index of. Okay, an index of expects the target character as a parameter, and it returns the position of the first instance of that character, the first time that character appears in the string, or it returns -1 if that character doesn't appear at all. The second method, substring, expects two integer parameters that tells us the starting and ending positions of the substring. Okay, so basically, it's like taking a slice out of the string. Okay, it returns a substring that runs from the starting position up to, but not including the ending position. Okay, so let's take a look at a short program that uses these two methods. Okay, so we've got a sample string, call it str, and we're initializing it with the value hi there. We search for the first instance of a space using the index of method. So we're saying, find me the first instance of a space in string and store that into end position. Okay, so we've got a sample string called str. We're initializing with the value hi there. We're saying now, okay, in str, find me the first appearance of a space and store its index in end position. Now, the other possibility is that end position could end up with the value -1 if there are no spaces in the string. That's obviously not the case with the string we're passing right here. We do account for that position, though. We're saying if there's no space, we're just going to use the whole string because it's all one word. So if end position is -1, then end position equals string.length. Okay, and that's going to be the upper bound on our substring. So then to extract the first word, we're going to say, give me the substring of string of str from 0 until end position. That includes 0, doesn't include end position. And then we're just going to print the result. So we'll print the index, end position, and we'll print the word itself, the first word in the string. Just to hit this home, a couple more examples. Here is a string in honor of one of my former students named Gilmar. Gilmar So Lonely. If we wanted to find out where's the first appearance of a capital G, well, that's going to be at 0 right there. That's what index of returns. Lowercase g will give us -1 because there are no lowercase g's here. The first space is at index 7. If we wanted to do the same with substring, well, look, the substring from 1 to 5 will give us from this I, including the I, all the way up to the R, but not including the R. Okay. Same with 11 to 16. If we passed it a single parameter, okay, rather than two, a beginning and an end, if we pass substring a single parameter, it'll give us from that index all the way to the end. So if we pass it only 11, this overloaded version of the method will end up giving us the entire word lonely from 11 all the way to the end of the string. That's a second overloaded definition of the method. We'll run through a couple of other string methods real quick. These you should familiarize yourself with. You're probably going to use them a whole bunch. We won't dwell too long on them in the video because that's boring, but I would suggest that you take a look through the slides after this and make sure you understand how to use all of them. That'll be crucial for what we do next in class. So length actually just returns the length of the string. I believe we've used that already. Equals compares two strings. That would be this string and the other string that we pass. Okay? And it will return true if they have the same value and false otherwise. Compare to is an interesting one we haven't really seen so far. Compare to basically is a way for us to compare the order of two strings. So it returns a negative number if the calling string comes before the parameter. So alphabetically, if the calling string comes before the parameter. Returns a positive number if the calling string comes after the parameter, or 0 if they're the same. So in this case, if I have S, and S is defined as APCS, and my string is the same as S, the same value, okay, we are saying, okay, S dot compare to BCDE, that's going to return a value less than 0 because BCDE comes after APCS alphabetically. S and my string have the same value, so if we compare them to each other, we'll end up with 0. Substring we've seen. This right here is a version of it that takes only a single parameter. I mentioned that on the other slide. It just goes from this starting position up until the end of the string. This is the version of substring that we saw before, giving us a start and an end position. Important to remember, it includes the start, but not the end. Equals ignore case we've seen before. It's going to return true if the two strings are the same, but it will ignore differences in case, which is often very helpful. A couple more. To lowercase to uppercase just returns versions of the string with all the same characters, but with the cases changed. Trim takes away all the leading and trailing spaces. Char at we've used before. It gives us the character at the index that we specify. And finally, index of, we saw before, gives us the first appearance of the string we pass in. Now, before we were using the version of it that takes a single character. Here, this overloaded version of index of takes a whole string. So I can actually do, if I have a string called word and it has the value banana, I can do word.index of NA, and the first instance of NA in this string occurs at index 2. So word.index of would return 2, and I could store that in an int, I could print it out, I could do whatever I wanted with that numerical value. Okay, finally, index of taking two parameters, a string and the start index. This will give us the first occurrence of a string, the string that we pass in, starting at the index we specify. So we saw before that the first instance of NA in banana is actually index 2, but if we specify start searching at index 3, so that means 0, 1, 2, 3, start searching at this A, then the first instance of NA is actually at index 4. And that can be really useful to us because it means we can search throughout a word where we expect a particular string to occur multiple times. And finally, last index of, pretty similar, also useful. It'll give us the index of, yeah, you guessed it, the last index of that particular substring in a string. Okay. Hopefully this really hits home the idea of overloading, that if we pass different parameters, we can define a method to do different things, even if it has the same name. Quick listing all in one slide of a bunch of helpful methods. This includes some ones that we didn't talk about. Take a look at some point. Play with these a little bit. Note that this method, split, it has this funny bracket here. That's for an array. We'll talk about that shortly, probably later this week. But for now, you could ignore that. Essentially, split will just take whatever delimiter we pass. Remember, delimiter is whatever character we say separates words, and it'll split a string up using that delimiter. So wherever that delimiter happens, it'll split the string. But we'll use that more once we have touched arrays, which is coming up. If you want to see everything else a string can do, you should click this link and go to the official docs. That is where you're going to find an exhaustive list of all the specifications of a string, and that would be a really helpful thing for you to visit and at least take a peek at. Now, one thing you may have noticed is that there are actually no mutator methods. I didn't list a single mutator method in any of those on the previous slides, and there are none for strings. And the reason for this is that strings are immutable objects. They're immutable objects, which really just means they're unchangeable. Once you make a string, you can't change its length and you can't modify any of its characters. Okay, you cannot change any of its characters. All you can do is copy it to a new string, to a different string, and make changes in the copying process so that it looks different. Okay, so this next program is going to illustrate how we can use the string methods that we looked at. We'll use actually length, index of, and substring to solve a problem that is at least a little bit more complex. Okay, so this program takes sentences as inputs from the keyboard. And the program shows the number of words in each sentence and, this is key, the average length of a word in the sentence. So it assumes that words are separated by at least one blank, and punctuation marks are considered parts of words. That's sort of a hand-wavy thing we did to make it easier. The program stops whenever the user just presses the Enter key without typing in a new sentence. So take a look at this code. It'd actually be best if you pause the video right now, look at it yourself. In 1 second, I'm going to go over it with you. Okay, we can see the overarching chunks of code here. Okay, we're taking inputs. That's what this while true loop is. That's just going to run forever until we break out. Then we are saying we're prompting the user, enter a sentence, taking whatever the user types in here. If they entered nothing, if they just hit enter, and input ends up having only the empty string in it, then we'll break out of this true loop and quit. Here we initialize a whole bunch of counters and indices for this loop. One to count the word, sentence length, the beginning and end position. Note that the end position here is initialized to the first instance of a space in whatever the user typed in. He will go until we don't see a blank. If we found a word, we're going to add 1 to our counter for the number of words. We're going to get that word using the substring method and the begin position and end position, and we're going to add the length of that word onto our accumulator for the length. And we'll update our indices, and then outside of that loop, if we found a non-blank character, at the end of a sentence, we're going to consider it a word. That's what's happening here. And finally, if there were no words, we have to account for that case here. Okay, we can see the two loops. The outer loop accepts inputs from the user, and it runs this nested loop to process each input. The inner loop is what processes each input. So the inner loop advances 2 indices through an input string. And every time we pass through this loop, those indices represent the beginning and ending positions of each word. So at the start, the beginning position is 0, and the ending position is the result of running index of with a blank character, with that space. And at this point, there's a couple of cases we want to consider. First possibility is index of returns -1. And that just means that a blank wasn't found. We didn't find a single blank. And at this point, we know that the nested loop has moved through the entire input string, and there's no more blanks anywhere. Or the loop is not entered at all. Now, if our beginning position is less than the length of the input string at this point, below the loop, the last word needs to be counted and extracted from the input string. Okay, so the program uses substring with the length of the input string as the ending position in this case. Okay, second case to consider is this. Index of returns an ending position that's greater than the current beginning position. This means that at least one non-blank character has been seen before encountering a blank. So in this case, the program continues in the inner loop and it increments the word count and extracts the word count using substring with the current beginning and ending positions. And the program basically then just increments the sentence length by the length of the word. So we're adding on the length of the word to that sentence length. Okay, third case is this. The index of returns an ending position that is equal to the current beginning position. And this happens if there are any leading blanks in the sentence or if there's more than one blank following a word. And in this case, the program shouldn't count a word or attempt to extract it from the input string. It should just continue in the inner loop. Okay, this is going to have the effect of scanning over the extra blank and just ignoring it. Okay, fourth thing is in cases 2 and 3, the inner loop is going to continue by updating the beginning and ending positions. Okay, the beginning position is incremented to 1 greater. The beginning position is incremented to 1 greater than the ending position. Then the ending position is reset to the result of running index of once more with a blank and the new beginning position. So the effect here is that it advances the positions to the beginning and ending positions of the next word, if there is one. So what you can see is counting the words in a sentence using these string methods is actually kind of complicated. We'll see an easier way to do this. Now, until now, we've used scanner objects really just to accept input of ints, of doubles, of strings, and also to read lines of text from the keyboard or from text files that we've opened up. So one interesting thing is that we can actually also use a scanner to read words from a string. It makes the whole process that we just went through a whole lot easier. So when we use it with a file, the scanner method next skips any leading blanks and it reads and returns a string that has the next sequence of non-blank characters. In other words, like the next non-space characters. If we use it with a string, next does the same thing. And the method hasNext returns true if there are still more words in the string to scan. So take a look at this code segment, which opens a scanner on a string now, not on the keyboard, not on a file, but on a string. And we use it to scan and display to print the words that are inside of it. This is our string, str. This is our scanner object. We're calling it reader. And we're passing it that string into the constructor. We're saying while reader.hasNext, while there's a next word, get the next word and print it. It's easy enough, right? The scanner is able to go through the whole string and break it into words. That's a lot simpler than the code we just wrote. Okay, the scanner handles all the tedious, annoying stuff, skipping multiple spaces between words and all the annoying corner cases that made the example we just looked at with those nested loops that made it so complicated. Awesome. Okay, so before you close up shop, here are the big things. You want to be able to describe the output of string processing code if I give you the abridged API. I don't need you to memorize all those methods necessarily. Eventually, you probably will have a lot of them memorized just from using them. But I assume I'm going to give you a short version of the API. You want to be able to use those string methods that we talked about today in order to do little tasks like replacing all the blank characters with new lines. And remember, because strings are immutable, that really means building a new string with new lines instead of spaces. Or, finding the first instance of the word the in a string. Or finding the first instance of the word the after the midpoint. Or counting the number of instances of the word the in a string. Tell me what it means that a string is immutable. And finally, use a scanner object, using its methods hasNext and next, to split a sentence into words. Awesome.